Okay, we're going to migrate back to kids. Kids, rodents, kids. I'm Rachel Dutton. I am very excited to tell you about a project that I have been building over the past few months called the First Foods Initiative. The First Foods Initiative is designed to be a thesis-driven, time-bound philanthropic fund that is going to test the idea whether early life fermented food exposure could actually prevent childhood atopic disease, and then seed the translational pathways to actually be able to act on that scientific foundation. So I'll talk more about this in a minute, but it's designed to be a 5-year program run in 2 phases to get real evidence-backed prevention solutions to families quickly using food, which can actually get to families much faster than going through therapeutic route. So the reason that I'm so excited about this is I think we have a really unique opportunity to have an impact on childhood health, specifically in this space of chronic immune conditions, which we really are seeing a crisis in the rise of chronic immune conditions in kids. So currently there's about 1 in 4 kids in the US who suffer from some form of atopic disease. So this includes food allergy, asthma, and eczema, among a number of other immune conditions. This affects about 1 million kids a year. Now, we know that these diseases are a result of challenges with the developing immune system. And in early childhood, it's really this kind of window of about the first 1,000 days of a kid's life where their immune system is developing and has the opportunity to develop in an appropriate way where they are tolerant and respond in a typical way to external interactions with their environment, or this immune system can develop in a way that may overreact to external factors, such as in food allergy and asthma. Now, this problem of chronic immune conditions has been studied for a number of decades, and one of the strongest scientific pieces of understanding we have about this is the importance of exposure to microbes during this window of immune development. We know that the immune system basically relies on exposure to environmental signals like microbes to properly develop. And this serves as a way to train the immune system and to be more tolerant of its environment. And we know that removing microbes from this equation through use of antibiotics and other things like sterilization of our environment actually leads to defects in the developing immune system. So we know that microbes are really important. But the question that I've been obsessed with for the past couple years is, what if the most important source of microbial exposure for kids in this early stage of life is something that we've completely overlooked? And what I'm talking about here is food. And in particular, what I'm talking about are fermented foods. Now, fermented foods are foods that are prepared through the use of microbial growth. So you may know some of these foods like yogurt, cheese, kombucha, beer, wine, things like that. They are a global tradition, so there are hundreds of different fermented foods around the world. But I think what most people don't know, and I didn't even know this until a couple of years ago, even though I've been studying fermented foods for almost 2 decades, is that fermented foods were one of the most common forms of weaning foods in the world. Weaning is the stage that happens so as you transition off of breast milk, so within this first 1,000 days of a kid's life, the transition to solid food. Now, in particular, the types of fermented foods that were really common as weaning foods were these soft fermented porridges, so things like grain and starch-based foods. They were very common dietary staples. They varied regionally depending on what the staple crop of the region was. But in general, these foods made excellent weaning foods because they were soft. They were basically pre-digested through the fermentation process, which made the nutrients much more bioavailable for them, so nutritionally, really good for kids. They were safe because they were acidified through the fermentation process in a time before sterilization of our food. But the thing that got me really excited about this is that these actually would have provided basically a daily dietary route of microbial exposure for kids during this critical window of immune development. And in the West, we've completely stopped feeding kids these foods. We've basically completely stopped eating these types of foods. So the question is, what if the rise in immune conditions in kids might be in part driven by these types of food that have completely disappeared from our diet? So we're missing this important aspect of immune exposure. So we know that fermented foods actually can shape immune development. There are several observational studies showing that increased yogurt consumption is associated with decreased risk of atopic disease, as much as 30 to 70% risk reduction. And we know in clinical intervention in adults that increased consumption of fermented foods in general shows significant decrease across chronic inflammatory markers. So we know these foods can interact with the immune system, but we don't really understand how. And if we wanted to bring these foods back in a safe and effective way for kids, how do we actually, what part of these foods should we focus on? So these foods are complex, like many foods. They have microbes, which could be involved in immune training. They have different metabolites, which are the products of microbial growth, that we know some of these are involved in immune tolerance. And there's components of the food matrix itself that could affect the gut microbiome and promote immune development in that way. So what I've been working on over the past 2 years is actually building a platform and open data sets to provide some of the first systematic data to map fermented foods and their connections to the immune system. We've done this initially from the perspective of thinking about inflammatory markers, so how do we understand the connections between these foods and inflammation, but what I'm proposing is to actually adapt this platform to look at the connections between fermented foods and immune development. This work initially has been funded by the Astera Institute, and we've partnered with the Periodic Table of Food Initiative, which is based out of the American Heart Association, which is doing broad metabolite mapping of foods. So how do we think this foundational scientific work will actually enact change and lead to durable change? We think this scientific foundation is really important to inform precision clinical trials. This clinical evidence can then feed into policy work and policy guideline change and regulatory pathways. This, I think, will unlock investment from the food industry, and at the end of the day, we hope to have accessible, effective products for families. We won't be able to do all of this within 5 years. For this part of the fund, we'll actually focus on these first two pieces of the puzzle. So the plan is to have a two-phase fund, the first phase being $20 million to do this foundational work and initial preclinical and early stage clinical work, and then scale it. I've been working in this field for almost 20 years across different sectors. I ran academic labs at Harvard and UC San Diego. I've worked in industry and nonprofits. My lab has done some of the first work on fermented food microbiomes, and we established some of these first open data sets connecting these foods. So we think this is a huge potential impact for kids and an opportunity to make something really important happen on a relatively short timeline. Okay, so with that, I will thank you all for your attention, and please come talk to me after.